Awesome. Great. Okay, so I'm about how deep do you think we are right now?
In meters or feet?
Meters.
In meters? Yeah, we're about 4 to 5 meters below the ground surface now here in Utqiagvik, inside what is commonly referred to as the Ice Wedge Tunnel.
Wow, it's really awesome. And the features that I see, you were about to explain something about, I guess, where the permafrost is.
Yeah, so we're very much into the permafrost right here, down around 4 to 5 meters below the surface. And if you look around here, Jerry, you'll see, particularly here, this is a type of ground ice that we refer to as ice wedge ice. And so this is what we were seeing on the surface before we came down the tunnel, in those linear depressions, in the low center ice wedge polygon terrain.
Right.
So this is what we're seeing manifest at the surface, forming these ice wedge polygon networks.
So the water is at the surface and starts to work its way down. Is that?
Yeah, that's one way. I mean, typically the way these ice wedges form is in the winter. In the wintertime, the ground surface cracks. And then those cracks fill with snowmelt water during late spring, early summer.
Right.
And that process plays out over several thousands of years. And what you get are these kind of vertical, more or less wedge-shaped features of ice that we call ice wedge ice. So that's what you're seeing here. You can touch it, you can lick it.
Right.
It's pretty amazing just to be able to sit and stand right next to an ice wedge.
Wow, an ice wedge. How old would you estimate this ice wedge to be?
So some researchers have radiocarbon dated some of the plant macrofossils in the wedge ice here. And I believe at this depth, these ice wedges are around 15,000 years old.
15,000 years?
15,000 years old, around this depth below the surface.
Okay, so I imagine what's below here is older.
Is older, exactly. And so if we come over here, I can show you something that's very, very interesting. And it is very widespread here. So, yeah, if you look here on the floor, I'll turn my light on. Oops. Yeah, look here on the floor. And you see liquid water. And we're within permafrost right now.
Right.
So, interesting thing here is the temperature down here right now is minus 7 degrees Celsius. But there's so much salt here in some of the horizons of the permafrost that we have these brine pockets.
Okay.
And so this stuff basically stays thawed year round, even though it's below 0 degrees Celsius. This sediment here would be considered permafrost. But the fact that there's so much salt in it, it thaws at temperatures that are like, say minus 8 degrees Celsius, minus 7 degrees Celsius.
So depending on how much brine is in the infrastructure or in the stratification, would that have some effect on the integrity of the landscape?
It does, it does, particularly for a lot of the homes that are built here in Utqiagvik. They're on piles.
Yeah.
So a lot of the homes are built up on piling foundations.
Right.
And the piles come through this permafrost here, that's more fresh, and then they actually anchor themselves down in this more saline type permafrost. So it could affect the behavior of the piles, actually.
And what would determine, the concentration of brine? Are there any environmental reasons behind it?
Yeah, there are. So if you go back in time, say around 100 to 120,000 years ago, so during the last interglacial period, this area would have been under the ocean.
Right.
And so a lot of the deposits here, the superficial quaternary geology deposits, are of marine genesis. And so they're inherently they have salts in the sediments that when the sea regressed and permafrost degraded, that basically salty sediment was incorporated into the permafrost here.
So we're like in a warming stage period right now. Is that could that potentially be accelerated because of global warming?
It could be. It's something interesting to think about, and it's not really well studied just in terms of how, in particular, saline permafrost is responding to global warming.
Right.
Right. So say 50 years ago, if this material was 3 degrees Celsius cooler, hypothetically, so say it was minus 10 degrees C, as opposed to minus 7 degrees C now,
right,
this would have likely been frozen.
Oh, that's interesting.
So we actually just submitted a proposal to the National Science Foundation last week. The title of our proposal is Thaw Below Zero.
Oh, that's great.
Yeah, so what we want to do is actually study these types of sediments, do a lot of lab experiments, and then define what these kind of key thaw/freezing depression points are.
Right.
Based on differences in the grain size of the sample, differences in the salinity of the sample, and also differences in the moisture content of the sample.
Yeah.
So hopefully, in the next year or two, we'll be able to help better address that question.
Yeah, I like the title, Thaw Below
Thaw Below
Freezing. It
Zero.
sounds like a
It's
great
good,
documentary.
Exactly.
Yeah, or a horror movie.
Yeah.
Wow, look at that.
But yeah, so in a little while, Misha's going back to get my drill. I'll probably drill a hole like right here in the corner so it's a little bit out of people's way. And I'll install a thermistor there. Actually, I should tell Misha to bring my thermistor too. I wonder if we could cell service down here. No, we don't. Let me actually pop up real quick.
Yeah.
I just want to call Misha so he can grab my thermistor. Yeah, and then check out the other side too.
Yeah, I will. This is really, really pretty incredible. I mean, to be in a permafrost tunnel at my age. Wow, it's really well illuminated. Oh, because there's a light there. It's like
There's a light over there. I should have done that on this other side.
I was like, wow, this is really amazing. There's some kind of like radioactive source that's emitting energy. Wow, look at that. So there are all sorts of devices. I'm not quite sure what these sensors do. Whoops. And of course I'm cracking all the glass. But if you notice, the temperature down here, can't really tell. It looks like it's hard to tell. Yeah, it looks like it's 10 degrees. I can't completely tell. But notice the crystals. So you have, it looks like soil beneath. And then you have water that freezes. And obviously there's going to be not much mineral deposits in the water. Otherwise it wouldn't freeze. But it is spectacular. Like they look like stalactites and stalagmites all over the place. Wow. So I think in a moment what we're going to do, what Ben's about to do, sorry about that, is drill a hole further into the permafrost tunnel to do a little more investigation. I'll ask him precisely what he plans to do. It looked like a terrorist.